All right, so as I mentioned before, we now have three methods to solving quadratic equations. So again, you notice the quadratic equation starts out in standard form. It's expanded, equaling 0. The first thing that we're going to try, the first method that we actually used was factoring. So once we have it in this form, we can try to factor the quadratic x and x, and then we have -5 plus 2 will give us the correct factors for that. Setting each factor equal to 0, we can get our answers x equals 5 or x equals -2. So factoring was the first strategy that we used. The second strategy was when we ended up having a quadratic, but it was in the form where we had a perfect square expression in x. So remember, this is like an a squared equaling a number. We used the square root property. Where we took basically, again, once it's a perfect square equaling another, we took the square root of each side. And in this case, we would end up with x minus 3 on the left equaling, and then plus or minus the square root of 50. So we have to remember that plus or minus in the square root property. But when we do that, we always want to simplify our square roots. The square root of 50 we could look at as the square root of 25 times the square root of 2. So we could simplify the square root of 50 into 5 square root of 2. So if we add 3 to both sides, we would end up with x equals 3, and then plus or minus 5 square root of 2. So again, if we have the square root method, if something's already set up into the square root method, we definitely want to use that. It's very quick to our answer. And yeah, I'll just leave it at that. So if we can factor it, we'll factor it. The square root property is great if the equation is already in a perfect square. If x minus 3 is, quantity squared is a perfect square, we want to use that square root property. And then finally, if none of those work, then we'll use the quadratic formula. So again, when it's in standard form, we want to recognize the coefficient of x squared is a. The coefficient of x, in this case is -3, would be b, and then the constant is -3. So applying the quadratic formula, we would have x equals, we have that big fraction bar, plus or minus, and then the square root. The first term is the opposite of b, so the opposite of -3 is 3, plus or minus the square root of b squared. Well, -3 squared is 9, and then I have minus 4 times a, which is 2, times c, which is -3. So that's all over 2 times a, which is 2. So with the quadratic formula, we then need to simplify. We have the two terms underneath the square root. We want to simplify that first. We'd have 9, and then -4 times 2 times -3. -4 times -3 is positive 12, times 2 is 24. So that'd be a positive 24. 9 plus 24 is 33. So we end up with x equals 3 plus or minus the square root of 33. That's all over 4. Now we notice the square root of 33 we cannot simplify. So there's nothing left to do. So in this case, our answer we could just leave in that form. So of course we know there's two answers, 3 plus the square root of 33 over 4 and 3 minus the square root of 33 over 4. But since we can't simplify that square root anymore, then we'll leave it in this form and be okay. So we got three ways to solve a quadratic equation. We have factoring. We want to try that first. We have the square root property. It's very efficient if I have a perfect square expression, like a perfect square binomial on one side and a number on the other. And then we have the quadratic formula as a fallback. Okay, so at the end of this page in your notes, you have some you try it's. And there's a video solutions of those you try it's with that. So I think it's a good idea to practice this now. Practice the quadratic formula and again realize that we do have these three methods to solve quadratics. All right.